All right, hello algebra students, and welcome to the 1.3 notes video. This lesson is on solving equations with variables on both sides of the equal sign. The learning target is I can solve a linear equation with variables on both sides. So some important vocab for us today. When we are solving equations with variables on both sides, there are certain steps and things to consider. So first, we're going to simplify one or both sides of the equation. We are going to use inverse operations to have all the variables on one side of the equation. So we're going to move all the variables, combine like terms to get them together. And reminder, inverse operations are operations that undo each other, like addition and subtraction or multiplication and division. We're also going to use inverse operations to have all constant terms on the other side of the equation. The goal is to, in the end, have a variable equals a constant. And you can write these notes in your notebook, or you can download the PDF off Canvas and do it in Notability. All right, so example 1, solve each equation. Part A, I have 5y plus 16 equals 6 minus 5y. Well, first, I want to simplify each side if possible. There are no like terms on either side, so we're going to skip that step. Second step was to get all the variables on one side. So I noticed 5y on the left and negative 5y on the right. Now, I find it easier to add 5y to both sides instead of having to deal with a negative. So I'm going to add 5y to both sides, and it's going to cancel out on the right. And then on the left, I have 5y plus 5y, which is 10y, plus 16 equals 6. And now I solve for the variable. So to get y by itself, I need to get rid of the 16. Right now it's adding. Inverse of addition is subtraction. So I'm going to subtract 16 from both sides. Those cancel out. I have 10y equals 6 minus 16 is negative 10. Now I divide by 10 to get the y by itself. And I have y equals negative 1. All right, and we can check our work by plugging in negative 1. If I plug in negative 1 to the top, I'll do this in a red color. I have negative 5 plus 16 equals 6. Negative 5 times negative 1 is plus 5. And both sides are going to be 11, which is true, so we're good. All right, part B, I have 10 minus 4x equals negative 9x. Nothing to simplify on either side, so I'm going to work on getting all the variables to one side. I'm going to start by adding 4x. So the x's cancel out on the left. I'm left with 10 equals negative 5x, because negative 9x plus 4x is negative 5x. Now I'm going to pause for a second. A question I normally get at this stage is, well, why didn't you add 9x first? You could add 9x. You should reach the same answer if you get x by itself with a constant on the other side of the equal sign. Why I chose to add 4 instead of adding 9 is because then I'd be left with 0 on the right side. So you can do that. It will work. I just prefer not to. So, all right, back to the equation. I have 10 equals negative 5x. To get x by itself, I need to divide by negative 5. 10 divided by negative 5 is negative 2. Positive divided by negative is a negative. And the 5's cancel on this side. So I have x equals negative 2. All right, example 2, I'm still solving each equation. But now we have stuff to simplify on a side. So I can combine those like terms, 3x minus 12x. 3x minus 12x is negative 9x. So I'm going to rewrite this equation. I have 7 minus 9x equals 3x plus 1. Now we're going to go back to the steps we were doing in example 1. We're going to get all the variables on one side. So I'm going to start by adding 9x to both sides, because if you do one thing to one side, you have to do it to the other side. They're going to cancel out on the left. And then 3x plus 9x is 12x. All right, so now I get all the constant terms on one side. I'm going to subtract 1. So I have 6 equals 12x. And now to get x by itself, I'm running out of room, so I'm just going to write that step up here. To get x by itself, I need to divide by 12. And 6 divided by 12 is 1/2. So x equals 1/2. If you want to write this as x equals 0.5, that's fine, same thing. All right, part B. I have 1/2 times 6h minus 4 in parentheses equals negative 5h plus 1. Lots to simplify here. I have a 1/2 multiplying outside of a parentheses. I can use the distributive property to simplify that. So 1/2 of 6h is going to be 3h, and 1/2 of negative 4 is going to be negative 2. So I have 3h minus 2 equals negative 5h plus 1. All right, now I'm going to get all the h's to one side. Because I have a negative on the right and negatives aren't as fun to play with, I'm going to add 5h to both sides. So now I have 8h on the left minus 2 equals 5h's cancel out, so equals 1. Now I want to get h by itself, so I'm going to add 2 to both sides. And I have 8h equals 3. All right, we're going to move that step over here because I'm running out of room. Last step, I'm going to divide by 8. So the 8's cancel out, and I get h equals 3/8. So as you see in my examples, it's okay to get a fraction. You might get a fraction. It's okay. All right, last example. We have 2 different things to distribute. I have the 3 on the left and I have the 1/4 on the right. So 3 times 3x is 9x. 3 times negative 4 is negative 12. And on the right side, I have 1/4 of 32x is 8x. And 1/4 of 56 is 14. All right, so I have 9x minus 12 equals 8x plus 14. Now I'm going to get all of the variable terms to one side. So minus 8x minus 8x. I have x minus 12 equals 14. Now I need to add 12 to both sides. And I get x equals 26. And that's my answer. Now, of course, you should be double checking these, so all 3 of these answers you can plug back into the original equation and see that we got the right answer. All right, so example 3 is also solving each equation. We have a negative 2 outside of a parentheses here. We're going to distribute that. So I have negative 8y minus 2 equals negative 8y minus 2. And then, oh my goodness, it's the same on both sides. We're going to work through it and see what happens anyway. So get all the variables on one side. I'm going to add 8y, add 8y. Then I get negative 2 equals negative 2, which is true. All right, so here's an important thing to write in your notes. An equation has infinitely many solutions if it is true for all values of the variable. This is what's going to happen in case A. This is going to be many solutions. Because no matter what I plug in for y, I'm always going to get a true statement. So here where I solve for the variable, I got a true statement. That means it has infinitely many solutions. All right, and then the other important piece of information is that an equation has no solutions, or no solution if it reaches an untrue statement. I'm guessing that's what part B is going to be, but let's work it out and find out. So I have a 3 to distribute. We're going to distribute that. I have 15x plus 6 equals 15x. Well, if I subtract 15x from both sides, Now I have 6 equals 0, which is not a true statement. So we're going to say no solution. All right. So many solutions if it's a true statement, no solution if it is an untrue statement. Now notice this question on the left at the bottom, what is an identity? An identity is an equation that is true for all values of the variable, infinitely many solutions. So that's what case A is. That's called an identity function. It's true for all values of the variable. What's important to know is infinitely many solutions and no solution. All right, some summary questions for you. How do you solve an equation when a variable is on both sides of the equation? Well, you move the variables so they're on one side. Remember, if you do one thing to one side of the equation, you have to do the same thing to the other side. It's called balancing the equation. Why is it important to start with isolating the variable to one side? Well, so that you can solve for the variable and get the variable by itself. That's easier to do if there's only one variable to worry about. All right, what happens when the equation has no solution? It's going to reach an untrue statement to have no solution. And then what happens when an equation has infinitely many solutions? That will, when you're solving for it, it will reach a true statement, meaning no matter what you plug in for the variable, it's going to be true. That's infinitely many solutions.